Hi, welcome back to this fourth part of the House T AutoCAD 2020 modelling video course. This is the state of play. We've got the outside walls done, the staircase is done, and we've used a couple of different techniques to model the timber dividing wall between the dining and the staircase. Used thicknesses on one side and 3D faces on the other side, and 3D faces to cap the gaps inside the doorways. Okay, we're going to look at this material now. We've got a concrete kind of unit in the middle of the building that goes up through both floors. So we're going to get a few of these layers out of the way so we can look at that in more detail using the off command here. Okay, we can, I need to make the concrete the current layer. We've got a couple of layers hidden in this file. You'll notice them here. I've got wall concrete G, so I can thaw that layer and make it current. Okay, and you'll see down here there's some shapes, and these are the window opening shapes that will go eventually into this wall. You can see the positions of the openings in plan along this line. So we'll just get the few more layers out of the way first, just so we can see what we're doing. Okay, there's a bit of 2D material here that we can get rid of, so just using the erase command. We will need to see those again. Okay, and this material's finished. We might need it later. Let's just keep that. Okay. So firstly, we'll trace the shapes here using a polyline. Okay, and object snaps minimized just to end point. Okay, we're in the world UCS because we want to trace this on the ground. Now you notice the line sometimes disappears. It's because I'm still in a shaded mode. Okay, so we'll deal with that in 1 second. Let's go back to 2D wireframe, and the newest lines then look much stronger on top. Okay, so another polyline on the inside, and I'm not going to bother with this cupboard here. I'm just going to expedite matters and leave that one out of it. Okay, now these two will extrude to the height to the underside of the slab, so that's to this point here. So extrude both of those, enter, and take them to this height, which is also 3000 millimeters. Okay, we've got a solid inside a solid at the moment, so we'll subtract from the bigger shape, enter, take the smaller shape, enter. Let's just check that we can see the floor inside now. Use shift and middle mouse, tip it over. Yep, see the floor. Okay, we can see the wall now that needs the openings. The shapes of those are down here. Okay, so back to 2D wireframe. Okay, this is sitting in the world coordinate system. X is running this way, Y is running that way. Okay, so we'll copy these using this endpoint as the base point, and this corresponds to this position on the wall. So Shift Control C, base point, the end of that line, and then pick the three shapes and enter. We now need to go to the coordinate system that suits this wall, and if you look at the cube, this corresponds to the right view on the cube, so we choose the right UCS. Okay, now Shift Control V, and the object should be in the same alignment as our coordinates. So we choose the endpoint here. Now before we can extrude these, we need to explode it. So X, enter, click on the shapes once, enter. They're now individual polylines which can be extruded. So we do all three at the same time, enter, we'll extrude them to the depth of the wall. Something's gone a little bit wrong there. I'm just going to backtrack a second. That's looking a bit higher than it should. Perhaps I picked the wrong position for the insert there. Let me just check. I'm just going to check the height of that wall for a second as well. Ah, we've lost 25mm along the way somewhere there. Not quite sure where that occurred. Oh, no, that's correct. Just taking the height there. Okay. I'm just going to check another thing here, just to check the height of this wall. 3000 there. Okay, alright. Falling foul of my own drawings here, to be honest. What I'm going to do is copy this upwards initially by 25mm. I'm putting ortho on. I'm going to go up 25, and then join those two together. Right. Now we'll do the Shift Control V. Okay, that's better. The top of those should be in line with the top of that wall. Okay, we'll explode them, then extrude them. Pick the thickness of the wall, and then we can subtract them. Pick the whole block, enter, then pick the three smaller shapes, enter. That's better. These kind of clean breaks. Okay, now, now I'm just going to move a couple of lines here up by 25mm. I've been working in my head to 150mm floor thickness, but on the drawing here it's 175, so I'll just move those up 25 just to make everything consistent. Yeah, there it is, there's the 175s. There's me thinking 150 in my head all the time, and it's actually 175 on the drawings. Okay, there's a couple more openings that we need to form in this block. We can't get into it at the moment. Okay, so there's a doorway here, and there's a servery opening on this side, so better to go to the world UCS first, and then we can put rectangles on those two shapes. Another rectangle here. They extrude to different heights. This one can extrude to the same height as the doorway on the brown object. Okay, so bring this layer back on if you haven't already. Okay, 3D wall wood. Okay, 3D wall wood G. Bring that layer back on. We can use it as reference for the height. Okay, so it's extrude. this shape first, enter to this height. Okay, but this one isn't quite as high. This is only 1600 millimeters high. Okay, so extrude, pick this shape now, enter, and this one is just 1600. Okay, then subtract both of those, pick the overall shape, enter, and then the two smaller shapes. Okay, it's turned into quite a complicated shape now. We've got quite a lot of holes in this. Okay, then on this side, we're still with the concrete, there is a shelf which is also kind of effectively the table in this room. So there's quite a big concrete shape that we've got here, and you'll find the shape of that in a drawing called Ledge Profile Basic. So open that and you'll have the shape of the ledge. Okay, at the moment this is just individual lines, so we need to join those together and pull and then close it so we can use it to extrude. Okay, so the command is pedit, PE, enter, pick any of the lines. It says, do you want to turn it into a polyline? Just press enter because we do. We then want to join the other portions. So it's the join option. You can grab all the blue items in one go, enter. So we've added 10 segments to that, and before we finish the command we can close the polyline. Then press enter to stop the command. So we should have the closed shape here, and the red line is actually the height of the gravel in the light well. Okay, so it's just slightly down from the window frames and the window area here, so that obviously any rainwater that fills in this area doesn't kind of come into the building. So there's a little bit of protection for the height there. Okay, so we'll copy this across to the other drawing, and this would be the base point. Shift Control C, use this as the base point, and then take all the objects, there's only two now, enter, go back to the original drawing. Better to look at this in 2D wireframe. Okay, but the profile is in line with this wall instead. Okay, so looking at the cube there, that corresponds with the front coordinate system. Okay, now Shift Control V, the profile's in the right orientation, place it at this point, and then explode it. So X, return, click this, enter. Okay, this can now be extruded to this point. So take the depth from the plan, take it to there. Okay, so all our concrete items done in the same layer. This is a bit harsh, chances are you might bang your knee right on the corner of that concrete. That would be pretty painful. So what we're going to do is soften these by filleting with a radius these solid. Okay, AutoCAD's okay at this. It's not quite as good as something like Rhino at doing this kind of job, but if it's a fairly simple operation like this one, it would be okay. Okay, so if you go to solid, and then on the solid editing area we've got fillet edge. You need to set a radius, and let's just go for 25 millimeters. Enter. Okay, let's go in a bit closer so you can see what happens. Pick an edge, and we can take this edge at the same time. So it previews the fillet. If it's the way you want it, press enter, and another enter to finish the command. You can see it's still sitting kind of active at the moment, so a final enter to stop the command. Okay, let's just have a look at that. Okay, so it draws a line or two in there. These are called ISO lines. Okay, but it is basically a curve on there. Okay, it's not segmental or faceted, it is properly curved. Okay, you find this with concrete buildings. Quite often a company comes along afterwards and basically shaves the edges off because it saves them getting damaged later. If you taper, if you chamfer edges or fillet them, then you often end up with something that's going to last longer. Okay, let's go back to the orientation that we were before. It's a bit easier to work with. And what we'll do now is deal with the gravel. Okay, so this is basically going to get filled up with gravel. Probably some ballast first. Could even just be polystyrene or something like that. Okay, so what we're wanting to do is to trace around the shape at this level. Okay, so let's go back to the home ribbon, and we want a new layer. Okay, a new current layer, 3D, let's use capitals, 3D gravel, and it's obviously going to be on the ground, but I'll put the G on the end. Okay, and I'm going to choose a bit of a different colour for this, 101, make it current, close. Okay, we want to be tracing this in the world coordinate system, so we're looking down on things, and use a polyline. Okay, so start at the end of the red line, go over to the other end of the sill. Okay, and the polyline cannot drop, it can't change its height. Okay, corner of the light well now, around to the bottom corner, then across to the concrete wall. One more selection, there's a change of direction here, we come along and then back, so this end point, and then close. Okay, use your close option wherever you can, it's just more definite. The red line's not needed anymore. Okay, this is an open, it's a closed polyline, but there's no surface there at the moment. Okay, if you use the region command, so it's REG, enter, it will change the polyline into a surface. So you click on the polyline, enter again, and we should have a green surface there now. Let's just check. Okay, just a quick note about regions. So let's just copy this to one side. Okay. Now let's add another region here. So I've just drawn a circle and I'll region this. And let's copy that. So these are all at the same height. Okay. A region is where the points are all coplanar, which means they all effectively have the same Z coordinate. Now that is true even if the thing is rotated. So if I rotate the whole thing here, all these items are still coplanar. There's no variation in the heights relative to each other. Okay, now they can be joined to each other as long as they're coplanar. They can be joined to each other, so that's now one region, and they can be subtracted from each other. So it's still effectively a flat solid. They can be extruded. So you can see how kind of a useful kind of 3D object the region is. if I copy a solid, okay, and I explode it, then each of these sides of the object are regions. So sometimes creating a solid just to get the regions is quite a useful thing to do. Sometimes I use that kind of method, create a solid so that I can actually get hold of the regions. So they're extremely useful for, you know, ceilings and floors that have got awkward shapes that you don't want to necessarily 3D face, which is quite laborious. Regioning can be a quicker way to do that, but they're, as the main solids, they're not quite so editable. Okay, so that's a convenient place to stop, because the next video we're going to look at windows and doors. So let's stop this one just at this point.